Welcome to the Age of Asparagus. If you haven't seen the intro to this tutorial series, you should go check it out to get some context for the project and see an example of the game we'll be making. By the end of this episode, you should have a little character that moves around and tracks the mouse cursor's position in the level. Alright, let's give this a go. Look at this. I got Godot open and it's like I've never used it before. So I'm going to cancel this. We're going to start a new project. Let's pick a better place than this. So I'm going to go into my Documents folder. And I already made this here because I'm tracking the files on GitHub and I'll be posting them there. So you pick your own spot here. I'm also going to create a folder. Let's just call it 3D game. Okay. You can probably be more creative than that. And I'm going to call the project 3D game as well. Oh, that little D there, that's annoying. 3D game. And we'll use OpenGL ES3. I'm going to full screen it here with Shift F11. And you might notice my editor is a little bit larger than normal. That is because I have gone to the editor settings and increased the display scale to 125% just to make it easier for you to follow along. Sometimes it's hard to read code on YouTube. It's a little small, the text there. So let's add a 3D scene. And I'm going to double click this and call it my level. We'll add a ground. I'm going to hit the plus there and we're going to type CSG. So a CSG is a constructive solid geometry, and it's just a bunch of different kinds of meshes you can join together. You can cut one mesh out from the other mesh, and it's really nice for rapidly prototyping levels. It also comes with a built-in collision, which is really nice. You don't have to add an extra node for that. So let's start with that. These CSG meshes have these little pink dots here, which you can use to resize and quickly build up your level. I'm going to undo that with some Control Z's. Whoopsie. Control Shift Z will redo to get me back here. Before I resize it, I'm going to go up to this icon and use Snap with the little magnet there. And now when I move it, it'll snap to the grid. So I'm going to zoom out with my scroll wheel and orbit around by clicking my middle mouse button and holding it and moving my mouse. So let's pull this out about 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll do the same thing over here. 10. Good. And if you want a flat plane, you could do that. Bring it down one, but I'm just going to leave mine thick. I'm also going to move it down one so that the top of the plane lies flush with our nice grid there. And that looks good. I'm going to hit the plus here, and we're going to look for a kinematic body. If I type body here, we've got 3 kinds of bodies we can create. A static body is an object in your game that doesn't move but still interacts. That would make a good floor or other objects that you might run into. A rigid body is something that would be interactive but affected by physics like gravity and friction and stuff. And a kinematic body is something that will interact with objects, but in order for it to move around, you need to script it. And that's what we want, as you can tell by that handy little player-y-like icon. If you accidentally created it and it's underneath your CSG box, make sure you grab it and put it directly underneath your level so that it is on the same indentation level as the CSG box. Why don't we double click that CSG box and we'll call it ground, and we'll double click the kinematic body and call it player. Now there is no player, there is nothing there. So let's, with the player selected, I'm going to right click it and add a child node. And this time we're going to add a mesh instance. Now remember, since we're working in 3D now, you want to stick with the pink nodes. There are corresponding 2D nodes which will all show up in this bluishy color here. So we have a mesh, which still doesn't look like anything because in the inspector here under mesh, let's click empty and choose a new capsule mesh. There it is, floating on top of our level. It is dead. Let's stand it up by rotating it with the red circle. That's rotating on the x-axis. And you'll notice down here in the corner as I rotate it, it is rotating in 15-degree increments because I have my snap turned on. So we want it to be up and down 90 degrees there. That's good. You can confirm that by going over here, clicking the transform, and just making sure X is at 90 degrees. Okay, now I could move the capsule up, but I don't want to because then it will get disconnected from my player here. So let's undo that movement, and I'm going to select the player and turn on this buddy so that we cannot accidentally select the mesh and move it. When we move it, it will move both the player and all of its children. So we'll move it down, and I'm orbiting around again. We probably zooming in. Let's turn off snap temporarily, and we'll just get it close. It can float a little bit. That's okay. And I'm going to turn snap back on, just in case we want it later. Let's add a material to the player. So let's select the mesh instance, and then we are going to, over here in the inspector, expand the material section, click empty, and we're going to do a new spatial material. Click the white bally thing that shows up, and this will let us edit all the properties. In Godot, the albedo is what parameter that affects the color here. So let's click on the color, and I'm going to choose a hue, a reddy hue, plummy reddy hue, something like that. Sure. Okay, and I'm going to click away, and there we got it. The ground appears bluey. Well, it appears extra blue when I select it, because the selected CSG objects get extra blue. If there are other ones, they wouldn't be like this. But it's still even blue when it's not selected, and that is because of our sky. So maybe we should add a light. Let's add a light. Select the level, and right-click, add a child node. Let's see what light options we have here. We'll go with, let's go with a directional light. That's a sunlight. That has a direction, but it doesn't matter where the sun is, where the light is, the effect will be the same. So let's just move it up from the middle, and we'll get it out of the way a little bit over here. And if I orbit around, you should see an arrow. There's the arrow. So the light is pointing that way. And you can see the light coming from this direction and hitting it. So if I rotated this a little bit, you'll see that the light changes where it's coming from. Now it's facing that way. Now the light is coming from the other direction. Okay. Let's just have the light coming from about there. And we want some shadows to appear on the ground here. So with the light selected over in the inspector, I'm going to expand the shadow section and tick enabled. But I cannot see any shadows, and that is because the light is coming exactly parallel, and there is no light to cause a shadow. So we need to rotate it down a little bit. So I'm going to rotate it, and there's our shadow. And you can just play around with the rotation until you get the shadow lighty thing that you like. That looks good to me, so let's stick with that. Also notice the light is now hitting our ground plane, so it looks a little whiter as well. So we have a player and level, and let's get it moving around. So with the player selected, I'm gonna click this attach a new script button, and we'll call it player. It's just gonna create it in the root of our game, which is messy and not a good practice, but we'll clean it up later if we need to, if the project gets big enough. But for just this little thing, it might be fine. Okay. We can get rid of this, and we'll use the process function. I'm going to select these two, and if I hit Control K, that will allow me to unblock a comment, and if I highlight a whole bunch, I can hit Control K here and toggle big sections of comment. That's really helpful. Get rid of pass. So in our process function, we're going to get the user's input and then move and slide our character, just like in 2D. So let's create a couple of variables. We'll have some speed for our character, and we'll have a velocity, which will be a vector 3. We need to, even though we're only going to be moving in two directions, we need to use a vector 3 for our kinematic body, which is expecting a vector 3 for its move and slide. And maybe later on we can add some jumping or something. Okay, so in the process function, we're going to reset the velocity each time this function runs, every frame, to an empty vector. And let's get some input. So if input, make sure you got a capital I there, dot is action pressed. And you do not want just pressed, you want pressed. If you do just pressed, it'll only trigger one time, even if you click and hold it down. So action pressed will cover us for clicking and holding. And we're going to use some built-in actions. Let's use UI right. Good. And make sure these are all lowercase. It should autocomplete, which will prevent you from adding any typos. Colon. And so if we're going to go right, let's do velocity.x, and we'll add 1 to it, plus equals 1. So we're going to do this for all 4 directions. That's annoying. By the way, if I paste and it's tabbed in, I can highlight both lines, and if I hit Shift Tab, that will indent the whole highlighted section. Let's get you back over there. Boom. Okay, we're going to change this to left. Good. Up and down. So for left, we'll have x is -1. For up, we're now going to use z, and up +1 sounds logical, and z -1 for down. I don't know if that will work. Let's check it out and make sure we got those directions correct. We also need to move the character, so let's go move and slide with our velocity, whatever that is at that time. All right, wow, we haven't even saved our project yet. That's not smart. We should be saving our project all the time. So left hand should be on Control S, and you should form a habit of hitting it regularly. Control S, okay. So let's save this level scene. We can just save it as level. Again, we'll save it just here in the root, like bad, disorganized game designers, probably. And we'll save our scene. Everything's good. Okay, we have a move and slide velocity. Let's see if we set this up properly. I'm going to play the scene. And what? Gray. We have no camera with which to view our level. Camera time. So select level. Let's right click it and add a child node. What cameras do we have available to us? We're just going to do the base camera. And like everything, it's going to show up here at the origin. Let's move with the camera selected. Let's move it up. It's snapping nicely, and we'll move it back. I can see the camera if I look in here. If I hold shift and middle click, I can drag up and down. I can pan. I can see it's facing that way. So let's grab it in the Z direction and move it back a little bit. What does that look like? What happens if we play it now? Yay! But that's not what I want the camera to look like. So let's go to view here, and we'll do 2 side-by-side viewports. And with the camera selected, we can click this preview button here, and that will show us what the camera is looking at. So now as we adjust and move the camera, we can see what the game's going to look like. Okay, that's good. I'm moving it up. I'm just going to zoom out a little bit here. Zoom up, and let's rotate it on the x-axis here with this red ring. Look down a little bit. Yeah, it's looking good, but we want to be further away. Okay, up. I can also grab this little red square here, which will move it in the plane that I want. And I want it to look down something like that. Yeah, that looks fine. All right, let's go back into our single viewport now. We can hit play. There's our level. And if I use the arrow keys, I'm moving very slowly and badly. And also, okay, my left and right is working, but my up and down is backwards. So let's go fix that. That's easy. We'll go back to our player script. And we'll switch the Z's from negative Z and positive Z. How's that? That'll work, right? Yep. All right. So we want to move faster than that. So instead of passing the velocity, let's update it here. So we'll set the velocity equal to itself times the speed we created, and I set it at 5. You can change that to whatever you want. And that new velocity multiplied by speed we will be moving in. Okay, how about that? Yeah, it's a decent movement. Maybe it could go a little faster if we wanted. But one thing you'll notice is if I go down and up, I have a certain speed, and left and right a certain speed. But then if I press up and to the left, I actually go a little bit faster here. And that's because we haven't normalized our velocity before we multiply it by the speed. So we want the velocity at this point just to be a direction. In fact, it might make sense to call this direction until we multiply it by the speed. But we're good now. So let's just go velocity dot, and we should be able to just grab the normalized velocity. So that's basically just a direction. It's a vector with a length of 1, and then we'll multiply it by the speed. And now when we move around, that's a little more natural, and it's pretty slow. So maybe we can make it to like 8 or something. I don't know. We'll probably be tweaking this a lot later, but ooh, yeah, that's better. Okay, so the next thing we want to do is we want the character to be able to turn and look at wherever my mouse is pointing on this plane here. So it's just a capsule, that's going to be hard to see, so why don't we give him some little goggles or something. Let's zoom back in here, and under the player we're going to add another child node. Let's add another mesh instance, and this time let's call it over in the inspector, the mesh, we'll give it let's do a cube mesh, and under expand material here we'll do a new spatial material. Click the sphere, and under albedo let's change this to let's do like blacky, charcoaly black. just because it'll look, I don't know, he's wearing shades. So because I have this turned on, children are not selectable, I accidentally selected away and back again. I can't actually select the mesh instance, so I gotta select him in the scene tree. And let's turn on the, let's go to the scale widget, and this is gonna snap, which is gonna not, oh, is snap off? Not sure, didn't seem, it's not snapping though, so that's fine with me. Let's just adjust this to look like something interesting. Oh, it's going through both, so let's squish it out and move it, boom. Move it up a little bit, boom. Yeah, here we go. Let's turn off snap. Cool, so he's looking in a direction now. Okay, I'm gonna double click mesh instance 2 here and call it eyes. And maybe I'll double click the first and call it body, just to make them easier to reference if we need them. Okay, so now we somehow need to script it to follow and turn and follow the mouse. So this is a little complicated, and it's going to be using rays and stuff. Okay, so here's how we're going to do this. Imagine this is our 3D world, and this here is the screen that we're looking through to play our game. This rectangle here will match the rectangle here on the front of the camera. And you can imagine if we had a mouse pointer, a cursor, on the screen, that it would have an equivalent position on our camera in 3D space, right here, which would be a vector 2 on our screen with an x and y coordinate. So the point we want to get, if we're pointing on our screen, right there, on our ground, which would be somewhere over here in 3D space. So somehow we need to find the 3D coordinate, the vector 3, of that point from just this mouse cursor on the screen. And how we can do that is if we have the origin of our camera, and then if we could get a vector that went from the origin of our camera and through or to where our mouse cursor is positioned on the front of the camera, something like this, a vector pointing out in that direction, or if our mouse cursor was over here in the top corner, which might be somewhere up here in 3D space, the vector would be pointing off in a different direction. At least that's the way it would be for a perspective camera. The calculations would be different if we had an orthogonal camera. And one of the reasons why the code I'm going to write in a moment here is more complicated than it needs to be just to find the camera origin is because that takes into account if you were using an orthogonal camera as well. But for now, we're just going to worry about the perspective camera because that's what our game is using so far anyway. Then, if we could take this vector and multiply it by a large number so that it extends off into a long ways away, much further than we need, out here, somewhere way off in 3D space, we can project a ray from an origin point off to some target point, which is basically like a laser beam. And the special thing about rays in game engines is that they can detect collisions with shapes that have collision detection in your 3D world. So in our case, as long as the ground plane has some sort of collision ability, then the ray will be able to detect where it collides with the surface of our ground, which should be the point that our pointer is looking at if we were looking at through the camera. And then using that, we could turn our player to face that collision point. So the hardest part of this is how do we get a vector that goes from the origin of the camera and points through the cursor's position in 3D space on the front of the camera? Well, thankfully, Godot has a built-in method that will give us this vector based on where the mouse cursor is on that screen. Let's do this in our level. We'll have our level be the kind of the boss and controlling everything. So I'm going to add a new script for our level, and I'm going to call it main. And in the main script, we can get rid of all the bottom stuff here. We're going to use the physics process. We have to use the physics process because there is a method we're going to use that only works within the physics process. Some information we need that is only available here. We're going to need to get 2 points. We're going to need to get a start point and an end point. So I'm going to create a variable called ray origin, which is going to basically be where the camera is. And from the camera, we're going to go to some target point, and that target point, which is a vector 3 as well. So in the physics process, we're going to get the mouse position. So we'll create a new variable called mouse position and get viewport method. We can get the mouse position. There it is. Okay, so what is that exactly? Well, one thing I'd suggest you do when you're not sure what's going on, especially what this means, like mouse position how in 3D space, well, it doesn't really make sense to say that. So we can debug this, and how I often do this is just print, we'll just say mouse position, like the name of the variable basically, with a colon and a space, comma, and then the variable. And then run it, and we should be able to see what's happening. So mouse position is 0, 0, so when I'm outside the game it's not registering anything, and there's the mouse position. So you can see in the top left is basically 0, 0, and then the Y value goes up as I go down, and then the X value goes up. So you can see this is screen coordinates in probably pixels. So I'm going to Control K that to comment it out. So we're going to set the ray origin variable, and equals, we're going to use that magical dollar sign to get other child nodes of our level script. Let's get the camera, and we are going to call project ray origin based on the mouse position variable here. What is this doing? This is probably the most confusing one. I'm not really sure. But the camera doesn't move, so I suspect that the origin should always be the same. Let's do that and that. Well, that's a complicated way of getting the camera's position. Control K that. Let's tab in there, and now we need to get the ray target. So these are points in 3D space. They're vector 3s. So I should say target. We're going to start at the ray origin, which is the camera's position in 3D space, and then we're going to go in the direction from the camera. So we'll start at the camera, and we'll project a ray normal. This is going to point from the camera to the mouse position, and we want it to go a long way. So let's times it by 1,000. Because I am zoomed in quite a bit, I'm just going to shrink this section here so that I have a little more room for my code. So here's where we got to use a little bit of magic here. So we're going to create a new variable called space state, and we're going to get the world. What does get world do? Get world can get us information about the physics of our world, and we're going to do something called, we're going to get the direct space state. Why? What does that mean? Well, because we can use that to find things in our world that are intersecting with our ray that we're going to create. Okay, so let's use this space state, whatever that magical thing is, and we're going to check to see what this ray intersects with. So we're going to intersect a ray. A ray is just like a line. The line is going to go from the ray origin, which is the camera, to the ray target, which is looking from the camera to the mouse cursor, and it just keeps going on for a long ways. And so as that line shoots out from our camera towards the mouse pointer in 3D space, it's going to interact with stuff. And this intersection is going to be a dictionary with a bunch of stuff in it. And we need one of those things. But first, let's make sure we're actually intersecting with anything. So we're going to go if not intersection empty, intersection.empty. So this checks if the dictionary is empty, and we want to make sure it's not empty. If it's not empty, then let's find where the position of the intersection. So we're going to go var, we'll just create a variable called pause for position equals intersection, and it's got a whole bunch of information in intersection, but the one thing we want is the position of the intersection, where that ray shooting out from the camera actually hits. The last thing we need to do is turn the player so that it looks at the mouse pointer. Okay, so we're going to use the $$$ magic again, and this time we're going to use the player node and use that beautiful look at. Where are we going to look at? Well, we're going to look at the position that we've discovered, which is the position our mouse touches that plane. And look at needs a second value, which is the up vector. So in this case, I can just do vector 3 dot up, because we're just using the default up. We have the gravity's not acting upside down and weird things aren't happening. So for now we can let's just do vector 3 dot up. That works. And now we should have some lovin'. We do not. Why not? Let's debug that. Okay, so are we even getting in here? Is the intersection empty? Let's find out. Print not empty. Okay. There is nothing here. Okay. We're not actually colliding, and that's because I did not turn on collision with our CSG. Instead of creating a collision shape here, we can just go to the ground, and where are you? Here, use collision. Let's turn you on and see what happens. Hey, look, he's looking oddly. Okay, and not empty, good. So we have a collision, and clearly our player is following it, although it looks like he's trying to listen to the pointer really carefully. Maybe we can shoot lasers out of his ears or something. So this is caused because what the look at method does, if we go to our script, we can, here's look at. So let's search help and go look at. We want the 3D spatial one. And you'll see that it rotates itself so that the local negative Z axis points toward the target position. Okay, so for some reason, our negative Z axis is coming out of its ear, our player's ear, which, there it is right there, look. So the positive Z axis is this blue one. And by the way, just a trick to help remember what all these colors do. I always remember RGB, you know, like the RGB colors, red, green, blue. Well, that's X, Y, Z. So red, X, green, Y, blue, Z, RGB, X, Y, Z. Okay, the positive Z axis is coming out of this ear. The negative Z axis is coming out of his other ear. So let's rotate the player. What we want is we want the player to be looking in the negative Z direction, because that's what that look at method does for us. So over in the inspector with the player selected, I'm going to go into the transform, and there's no rotation. So let's rotate the player. Is snap on? I'm just going to turn snap on here and rotate the player to look in there, negative Z direction, away from the blue arrow. And what happens now if we try it? What? He's still listening. Okay, that didn't work. Let's not rotate the player. Instead, let's rotate the body, because we're using the player for stuff, and by transforming it, it's going to cause us problems. So let's just rotate the body mesh to face that direction. Of course, the body mesh does nothing because it's a symmetrical capsule. I'm going to undo that. Let's take the eyes, because the eyes are on the body, so they should be a child of the body, actually. So now when we rotate the body, the eyes will rotate with it. There we go. So now the eyes are facing the negative Z direction. How about now? Hey, it works. We obviously have one small problem still, and that is this player is really intent on looking at this arrow, even right down to the ground. So although we want it to look at the arrow, we want to look at the arrow as if it was kind of eye height for the player. We need to change the Y value of where it's looking at. Let's go back to the level script here, and where we say look at this position, let's create a new variable called look at me, and it will be a new vector 3, and we want it to use the same X position and the same Z position, pos.z, but for the Y position, we just want to use the player's own Y position, right? Because we want it to kind of look at its height, or at least somewhere up there. So let's go get the player again with the magic $, player dot, and we want its translation, and we want its Y translation. Okay, so now instead of looking at the intersecting position, we're going to look at this new point called look at me, which is just the intersection position, but moved up by the same height as the player. Hey, cool, eh? It's working. All right, so in the next video, we will get rid of this not empty. Let's do that now. not empty. I just Control K out all these comments because in future debugging it becomes really easy just to add some of these things back in. Alright, so in the next video we're going to add some weapon mechanics and stuff. Carry on, hopefully. I don't know what to say. Don't forget to save your work. Control S. Save it all. Save often.